thank you very much for being here. I appreciate your dedication, being there in the afternoon as the conference is closing and all of that. I really appreciate your presence. Thank you so much for being here. So for those of you, well, most of you know me, but just in case, I'm Frédéric Desbiens. I manage IoT and edge computing programs at the Eclipse Foundation, and it's my pleasure to be with you today. So if you want to reach out, you see I'm on Mastodon, Twitter, not so much, so anyway. I invite you to do the same because Elon will try to charge us quite soon. So today is really a battle between two technologies, one being the established, of course, player OPC UA, and Sparkplug being, you know, the young challenger. But a few words about myself before, if just in case you don't know me. So I've been in IT for, at this point, more than 25 years. I worked as a software developer, architect, and a product manager, and now, well, program manager at the Eclipse Foundation. I worked for large companies and some smaller that I didn't put on that, and don't hesitate to connect with me. And I wrote a book, not to brag about it, but rather to help the Eclipse IoT community. So the whole point of this book is to provide a comprehensive overview of the top 20 to 25-ish most popular projects we have in the ecosystem. So if you're new to this, you don't know where to start, this is a good starting point. And believe me, although I make, of course, a bit of money out of those sales, I won't drive a Mercedes or Porsche anytime soon, unfortunately. So our agenda for today, really three simple things. First, we'll present our contenders, and then we'll dig a bit deeper into Sparkplug to show exactly how it works, and so that you can understand the benefits it provides over OPC UA. And then we'll have a look at the wider Sparkplug ecosystem, you know, how it lives at the Eclipse Foundation. So this is you know, where I ruined my own intro. So we had this feisty battle music and all of that, and I promise you a battle, but really the message there that you should remember is that those technologies work together, right? Of course, one is better than the other, right? You know, I'm a bit biased about that, but the thing is, really, there's a large base of OPC UA devices and, of course, software components in the wild, right, in actual factories all over the place, and we know how much time it takes to operational technology to evolve. Right? So OPC UA is with us for maybe the end of times, like COBOL or something. In any case, it will be there for a long time. So of course, we need to coexist and work together. And this presentation covers that, right? So our contenders, if you're less familiar with them. So OPC UA is a technology that exists in its current form since 2008, okay? However, there was a previous version which was just OPC, okay, without the UA, which stands for Unified Architecture. So before OPC UA, there was OPC, and OPC was really something Microsoft-centric. Okay, Microsoft was, you know, one of the drivers of this initiative, and the original architecture was around COM and horrible things that are better left in the 90s. Anyway, so it's a client-server type of protocol. Okay, and you can do PubSub now. There's an extension to do that, but nobody, or little to nobody, implements it. And the problem with it is that when it's implemented from one vendor to another, it's slightly different, so it doesn't operate well. Anyway, OPC UA at its core has been built for IT networks. So you assume that you have Ethernet, essentially, and that it will work. Okay, and in most cases that's fine, but of course we are in a world where devices are in the field, battery operated, in hard to reach locations and all of that, and of course you see the problem right away. Those types of networks that connect those devices are not stable, are not as reliable as a corporate IT network. OPC UA is under the stewardship of the OPC Foundation, and if you try to acquire the core specs, you will have lots of paper, really lots of paper. That's thousands of pages just for the core specs, and then you have the information models, so data models that are reusable that you can use, so it piles up, really. And it's complex, that's the thing. There are several different potential profiles that you can implement. And of course, someone will say, hey, we are OPC UA compatible, but before you have no idea what this means before you dig into the documentation and figure out what profiles they implement and all of that, and then it doesn't work with your robot because, anyway, it's a mess. Now, the first challenger that we've got there is MQTT. So MQTT has been around since 1999. It's a publish and subscribe protocol from the ground up. And it has been built for field networks. So originally, Alan Nipper and Andy Stanford-Clark, the two co-inventors of MQTT, created this to administer remote pipelines, somewhere in the US. And they were using satellite connections. And doing that over HTTP or other IT-type protocols was way too heavy and way too dependent on the quality of the network connection, so they came out with MQTT as a replacement for that, okay? MQTT is under the stewardship of Oasis, and the spec itself, even in its latest version, version 5, is about 150 pages. So it's quite simple. And of course, as you know, if you work in IoT, industrial automation, or edge computing, there's a wide ecosystem of open source and commercial MQTT brokers and clients that you can rely on. But one of the great things about MQTT is that you can publish any data anywhere. And one of the bad things about MQTT is that you can publish any data anywhere. So there's no agreed on data format, and there's no agreement or predictability to the topic structure. When you use MQTT, you publish to a topic, and the topic is a string with slashes to delimitate levels, okay? So it's like the folders on your hard drive. But this is completely arbitrary. Right? My robot will send stuff to /robot/telemetry. And your software is expecting telemetry on /telemetry/robot. And there, it doesn't work out of the box, right? And of course, you have no idea what is the format of the data that I will send. So Sparkplug is there to solve that specific problem. So Sparkplug has been invented by Alan Nipper, so one of the co-inventors of MQTT in 2016, and his company, CirrusLink Solutions, contributed Sparkplug as a specification to the Eclipse Foundation in 2019, okay? So out of the box, of course, it works well on field networks because it uses MQTT as a transport. Of course, the steward of, yes?
That means your spec is twice as big. You have to use the other spec too.
Indeed. But the thing is, if you just implement Sparkplug, you don't need to implement MQTT. The question was, or the comment was, you have double the work because if you work with Sparkplug, it's 150 pages MQTT and 140 for Sparkplug. But of course, given the mature ecosystem, you don't implement MQTT from scratch. Well, you can if you want to show that you are a rock star developer. I don't recommend it. But that's a good comment. I appreciate it. And yeah, so Sparkplug is really defined by its simplicity. So there are two historical problems with OPC UA. One of them has been resolved, okay? And I was trying to find a good way to express this in a way that you would catch it right away. And I found the perfect picture for that. This is Bill Gates. And Bill Gates sitting on tons of paper. So historically, OPC UA was tied to the Microsoft ecosystem, first problem. Second problem is, of course, the complexity of the spec. Now, it's not tied with OPC UA anymore to Microsoft types of environments. Microsoft is still a big backer. And I'm not saying this is bad technology and that Microsoft is bad or anything. Microsoft is a fantastic member of Eclipse, right? But in this particular case, you had really vendor lock-in initially, and this has been resolved in OPC UA. But the complexity stays. And there's another problem with OPC UA, which is this. OPC UA is a fantastic ecosystem working behind closed doors, okay? Oh, come on. We are in Germany, isn't it? I'm putting Versailles in your face, so sorry. So, OPC UA is a wonderful ecosystem working at a distance from the general public, right? From their high mountain or something. And that's the problem. I mean, you need to be a member of the OPC Foundation to get access to the specs, to get access to the testing tooling and everything. And this costs money, so there's a barrier to entry there. Of course, there are open source implementations, but if you are serious about working with it, you need the docs, right? And so that's not the way that we roll at the Eclipse Foundation. Okay, we do things differently, and you will see a bit later how different things are. But suffice to say, I don't like that. Well, I would love to live in a place like that, let's say, but yeah. Yeah. I know how sensitive this is, so, you know, but, you know, I didn't have the time to find a new or a better equivalent castle with a free photo in the surroundings. All right. So one thing to remember out of this is that really out of the box, since Sparkplug is simpler and since, as you will see, we have an open source TCK that you can download, it's much easier to be interoperable in the Sparkplug ecosystem, and of course simpler to implement given that you have a tiny bit of documentation to read only. And so just so you size really the difference in scope and features between OPC UA and Sparkplug. So this is the standard diagram if you go to their website where they explain everything that's in OPC UA. And so you see the famous information models, and you see the meta model and information access and all of that. And when I say that the pub sub inside is limited, really, you see it there. It's just good for data and event notifications, but not good for device discovery or other things that are happening in a normal OPC UA deployment. Okay, and this is a problem because, right, you will still have some client server or, you know, request response infrastructure or, you know, usage of those patterns in your infrastructure. And interoperability is really hard to achieve because of the complexity of the architecture and the fact that there are so many profiles that you can implement or not, that in the end, it's a mess. Yes?
I'm surprised you didn't say anything about security in OPC.
Yeah, this is an intro level talk, but yes, we could give a full talk just on that. So the comment was about security in OPC UA. It's really complex as well. It's nearly, to make a parallel, it's nearly as nice as quality of service in DDS, for example. If you're familiar with that, it's okay. So how does Sparkplug specifically improve an OPC UA implementation? If you use that, let's say, to bring your data to the cloud and to integrate with the existing infrastructure. Well, essentially, there are three basic things. First, you can access literally data from the cloud and send it to the cloud in a simple and secure way. Okay, there are no cloud service that will accept straight OPC UA, and in any case, the thing is, you would be opening firewall ports and all of that for the whole thing to work. With MQTT, the thing is that you're making outgoing connections to a remote broker. So out of the box, this is more secure as a pattern, right? And the other thing is that, of course, you don't need to change anything to your IT policies on the local network for MQTT to work either, apart from maybe authorizing traffic on the specific port that the broker is connecting to, and that's trivial to do today with modern networks. The second thing is that really Sparkplug enables you to build a unifying namespace for devices and applications. The thing is, in OPC UA, you are client server. So you query the little server on your robot in order to get the data, but this gives you the data without the context, right? You have to build that context yourself in order to contextualize the data properly. And in Sparkplug, you don't need to do that because of the way the topic structure is built, and we will cover that in an instant. And the third advantage is that, of course, since, you know, MQTT and Sparkplug on the top of it are publish and subscribe. This means publishers publish, and whoever is interested subscribe to the messages. So there's complete decoupling between, you know, the applications or devices producing the information and the ones that consume them. And that, once again, is better because you don't have those point-to-point integrations that are really messy to manage as long as you start getting more devices and more software components. So to synthesize, Sparkplug apps are easy to deploy and rely on outbound connections, and for that, it's much simpler. So this is the basic Sparkplug architecture as shown in the spec. Well, in the spec, it's a bit less pretty than that. There are no colors, and it's anyway, but that's literally the same diagram. So the broker, of course, is at the center of everything. And then you have a number of applications that don't necessarily speak Sparkplug natively. That's perfectly fine. And on the other hand, you've got your MQTT edge of network nodes that are Sparkplug enabled, the SCADA system and all of that. And to those edge nodes are plugged devices or even directly sensors. So those don't necessarily speak Sparkplug. It's okay. The edge of network node does the translation there. So a good example would be, I've got a bunch of Zigbee sensor wirelessly. They connect to this one. So they produce data in Sparkplug format, and this one sends it over MQTT, for example. That would be one potential topology there, okay? But the edge of network node ensures that all of those devices are seen, so to speak, by the Sparkplug infrastructure because they do some functions on their behalf. And as you see, this is quite simple, right? Now, dig it a bit deeper, okay? Out of the box, Sparkplug applications are interoperable. And this means essentially we have a common data format and a predictable topic structure, okay? And this solves the main two problems with MQTT. So the topic namespace is like this. This is a version namespace. So right now for Sparkplug version 3, okay, the payload format is Sparkplug B. And this is version 1.0 of Sparkplug B that we are using. So this means over time, as we get new versions, Sparkplug version 4 will have payload format C, okay? It's already decided by the spec project team. So you can have multiple Sparkplug versions running out of the same broker because the root of your topic structure is literally the version of the payload. Okay? Then you have a group ID that you can use to segment things according to the structure of your organization, the message type, edge node ID, and optionally, if you have devices connected to the edge node, a device ID. Okay? And then you have several message types. I'm not covering that in detail, but to simplify things, there are birth and death certificates for edge nodes and for devices. So the birth certificate is, hey, I'm here are the metrics I will report about. The death certificate enables you to know if the device is online or not, in the sense that this is using MQTT's last will and testament feature. So you will just receive this message if the device is disconnected or disconnects on its own, if it is shut down voluntarily. Between the two, you know that the device is online. Okay, and you don't need to do polling and response to determine that it is online or to get data updates, okay? And then there are other message types, but the one thing to remember about this is that Sparkplug works for telemetry. Those are data messages, and it works for commands sent to device, so those are command messages, okay? And you have those for edge nodes, and you have for devices, essentially. So this means when we have a topic structure like that, that will provide context to the data, essentially, because we know from which group ID, from which edge node, from which device, ultimately, it comes from. So we have the full context there. We know what we are talking about in the physical world, okay? The payload format for Sparkplug, okay, is something really, really different than what you see in OPC UA. OPC UA has those information models. They try to represent the ultimate water pump in a very abstract way that's supposed to make it work for everyone. We don't do that. Sparkplug is, the payload is there to represent any metric or set of metrics, whatever you have in your system, and that's all. Okay, but since it's common, anyone in the Sparkplug infrastructure can parse it or produce it. So the encoding used for the payloads is Google protocol buffers. So this is a highly efficient binary encoding. And here in my slides, I represent it in JSON because you don't read binary. I don't either. We're not machines, or maybe this is the ultimate gacha, right? Or captcha. Anyway, yeah. So we provide on the repository the actual proto file, the schema for the encoding. So you can use that, and depending on which language you use, it will generate skeleton classes for you to use, no problem. And really, this is a very simple payload where I didn't put anything in terms of metrics. I left it empty, so it's smaller, just to show the structure. And in the body, you can put arbitrary data. So if you want to transmit an image, for example, you could do it as an array of bytes, okay? But the actual metrics, the one thing that's really interesting goes there, okay? And so our metrics, they are always defined as key value data type, and you can add optional metadata about anything, really, it's up to you, okay, depending on your needs. There's also the concept of data sets and templates. So of course, if you have very complex data structure that you want to repeat, then you can use templates, and you just refer templates by a numerical ID. So this is way smaller on the wire than having, you know, complicated names or things like that. It's up to you to choose those integers and what they mean, right? So there's some modeling involved, okay? You have a question?
Yeah, my question is units of measure. So one of the things that goes wrong very often in systems is I send a data and I don't say what the unit of measure is. Somebody interprets with another unit, and the system crashes.
Yes.
How do we handle that? Because I don't see anything about units of measure here.
Exactly. And so the answer there is fairly simple. So the question is about units of measurement. How do I represent that in Sparkplug? And right now, it's in the optional metadata. Okay, you would define it in your own way, but we have Sparkplug version 4 on the way, and in Sparkplug version 4 we will normalize this. Okay, this is something that has been, and when I say we, it's not me, it's the committers of the spec project. Pardon me, committers, if you see this video. Okay, so this will be standardized and explicitly managed in the payloads for the next version. For the time being, you do it on your own, and of course we recommend using a reference which would be an international standard or something like that, not to become crazy, because if you start defining those as your own little thing, it will be tricky.
There's a Java JSR that does a very, very good job.
Okay, so the comment is that it seems we have a Java JSR doing that. So
it's been done.
Okay, it's been done. Okay, fantastic. So a useful reference if you work specifically with Java, at least.
It doesn't matter. It has nothing to. I mean,
yeah, of course.
The whole why, what were the units? How do you talk about them?
Okay.
You know,
Yeah. It's language independent.
Yeah.
Okay, good to know. All right, enough on this. So you see a typical metric represented there. So it was really cold outside on that particular night. Or no, not cold, 23 degrees, that was still summer in this case. But on the next one, you see them in action. So a birth certificate lists what I will report about as a node. And then the updates are smaller because you don't repeat all of that information. So the birth certificate is bigger, and after that, you slim down your payloads. Of course, this is just reporting about one metric, but that's what would filter on a single slide. Is better like that. But you see that the temperature became colder between the two, -25. If you analyze the timestamp, that's literally the temperature outside my home when I did that particular slide. And here is a short code sample in Java showing how it works in the real life. So this is from the Eclipse Tahoe project. Tahoe is the open source implementation of Sparkplug that we have at Eclipse. It has several language implementations, right? But the only one up to date right now with the latest version of the spec is the Java one. So I picked that one, and we have lots of Java-loving people at the conference. And I love Java. But in any case, you see this is fairly simple, right? We have an object mapper. We have the payload decoder. We decode the message in this case that we are receiving. So that would be probably a command message that I'm expecting from the SCADA system. And that's it. Right? So no need to figure out the payload, no need to figure out the structure, straightforward enough. All right. And of course, one thing to remember about all of this, and I talked already about the metadata, but this is key. OPC UA reports strictly about the basic tags, the basic data value. In the case of Sparkplug, you can add all the metadata that you want to contextualize this and make this more useful from a business perspective. So it's not just about the tag value, it's really about objects, full objects that are reported about. There are a few interesting other things about Sparkplug. For example, in Sparkplug, you've got auto-discovery of the edge nodes and devices because we've got those birth certificates that they publish. So I don't even need to do a multicast to announce to the world that I'm here as a new node, right? I publish that message, and whoever is interested will know. And if they don't care, well, that's their problem. Binary payloads, so slimmer on the wire, really important because we want to be able to deploy not only in the factory, but even outside. Lightweight, since Sparkplug is simple, then it's really easy on system resources, and of course you can have very efficient MQTT brokers that you can deploy on very constrained devices as well. So from a deployment perspective, it's, excuse me. It's very easy to deploy Sparkplug on constrained devices, not so much with OPC UA. The Sparkplug ecosystem. So we're talking a bit about my favorite topic, the Eclipse Foundation. One thing to remember about all of this is that Sparkplug is built in the open. And what that means, the specification, sorry, the spec, the TCK, Technology Compatibility Kit, so a test suite that you can download to test your implementation for conformance. All of that is built on GitHub. You can grab it straight away. But the thing is, you can propose new ideas for the spec as GitHub issues as well. Everything is done in the open, not somewhere in Bavaria, and I'm sorry for insulting all the Germans, all the local Germans in the room, right? So this is really different from the OPC Foundation's approach, because we do all of this in the open, transparently, and you don't need to be an Eclipse member to jump in. Of course, we would love you to, but this is not mandatory. So anyone can implement Sparkplug free of charge, no royalties, nothing involved, and anyone, of course, can download the TCK and run it against the implementation. Everyone can propose new ideas, no membership required, and really end users can pick validated products from our official compatibility list on the Sparkplug website. So we have a logo program, and essentially Eclipse members, this is where membership is mandatory. Eclipse members that have products that pass the TCK can list, request that they are listed on the Sparkplug website, essentially. So also, Sparkplug is on its way to be an international standard. Yeah, this is literally the first Eclipse specification transposed as an ISO IEC international standard. You have a comment?
Yeah, I just hope you fixed that UUID, because what you showed was not a UUID. So UUID has a standard format.
Oh yeah, of course.
I have this same problem with Covesa. They say they have a UUID, but it's not. It's just some ID that's unique in some file. And that's a bad thing.
Yeah, so in my case, I auto-generated something really quickly when I built the slide. So the comment was about the UUIDs in the payloads I showed a few slides ago in the technical segment of the presentation. You are correct, yes.
Okay. So there is an understanding that that should be a real UUID.
Yeah. Yeah. And so Sparkplug is on its way, as I mentioned, to be an international standard. So I had the proofs in hand from the ISO publishing team a few weeks ago. This is a big international bureaucracy. It would take maybe a few more weeks, but we are this close to get it officially. But this is a done deal. We've done the work. We're just awaiting them to officialize that. But if you click on the link, you can access the official page, and you see exactly the status where we are in the pipeline. Okay.
Is it based on the new version that you were talking about?
Yes, this is Sparkplug version 3. So the question is the international standard based on the latest version of Sparkplug? Yes.
Will that be the general pattern, that you evolve the Sparkplug specification as part of the Eclipse Foundation process?
Yes.
And then from time to time you update the ISO standard? Is that the idea?
Yes, so the comment here from Kai is that we intend, or is asking if we intend to maintain Sparkplug at Eclipse and then from time to time push that and update the international standard. This is exactly what we have in mind, and this is what you see on the slide, in the sense that the EFSP, the Eclipse Foundation specification process, up to now was just in the Jakarta EE world, right? And we literally invented it for that. However, now with Sparkplug, we applied it for the first time outside of that scope. And the way things work with the EFSP, we don't accept specs that are just a document. You absolutely have to have the spec document, APIs when it applies. Sparkplug doesn't have APIs because we run on the top of MQTT. You could see it as its API, so we don't need anything to document there. And the TCK is mandatory, so we don't accept specs that don't have a public test suite that people can download. And those 3 artifacts are versioned together and ratified together by the Sparkplug specification committee or the Jakarta spec committee depending on which working group we are talking about. But when we submit to ISO IEC, all we submit is the document and optionally the APIs, okay? Because they don't care about the software artifacts, and it would be really complicated to get that through the transposition process. You have a comment?
Yeah, another important point is protocols.
Yes. Yeah, in this case, we make a reference, of course, since MQTT is an international standard itself, in the Sparkplug specification, we make an explicit reference to that standard, and we are good in terms of APIs, so to speak. And protocols, yes. Yeah. So this is currently the Sparkplug gang. So on the top row, you have the strategic members of the working group. And on the bottom row, you have our participant and guest members. So we have academics interested in this, and of course, various software and hardware vendors. So up to 22, for example, they make smart little boxes that you can deploy in your factories. So the one thing to remember from all of this today is that Sparkplug can not only improve your OPC UA deployments, because you can take whatever data you take out of OPC UA and bring that data to the cloud with Sparkplug, and some people do just that in the market right now. But really, Sparkplug is the cornerstone of future projects for industrial automation. Really, it is simpler, it is slimmer, lean and mean, as it should be, as the Eclipse Foundation is in the way it operates as well. So, thank you so much for being here once again. I really appreciate your presence in this afternoon. And if you have any last questions, we may take them at this point. So, any additional questions? I mean, we did this pretty interactively as we were going on, but...
So that unit standardization doesn't...
please wait
So the unit standardization that you said is in the latest, that's not part of the ISO standard?
Yeah, it's not part of the ISO standard. So right now, let me, I didn't put a timeline slide. I didn't want to bore you to that, but the sequence of events is this in terms of the international standard. So in November 2022, the Eclipse Foundation obtained what they call the status of publicly available specification submitter at ISO IEC GTC1. So this gives us the right to push our stuff, or try to, because of course they can reject it, right? After that, we ratified Sparkplug version 3 using the EFSP in November of 2022 as well, and we started the transposition process for it immediately. At that time, it was version 3, so it doesn't have this standardized model, let's say, for units of measurement. The ballot to ratify or not our submission was between February 2023 and May. So that's always 12 weeks per regulations of JTC1. It was successful. So at that point, we know we have it, right? But we needed to produce documents in A4 format for whatever reason. And so by August, I had submitted that and everything was clean. By September, I had the proofs, and they will publish it by the end of the year. So now, what happened in the meantime is that in June 2023, the Sparkplug specification team adopted the roadmap and feature set for Sparkplug version 4. Okay, this is all on the GitHub. So if you are really interested into this, I can point you to specific files in the repo that explain all of that. We have markdown files describing everything. And I can point you to the GitHub issue where they discussed what they have in mind for units of measurement as well. So everything is in the open there. It's just for the time being a bit hard to navigate, but I can help you out with that.
Thank you.
Any other questions or comments?
Question, maybe stupid questions because I'm completely new on that. It's about, I would like to know if there is any desire to implement Sparkplug with 4DIAC project as well.
This could be done. 4DIAC Forte per se doesn't require any specific protocol, right? It's just a binary that runs on a PLC and does things. So if you write your Forte runtime and then add an MQTT library, and then, of course, implement or use whatever we have for C, but I think it's a bit behind. But suppose you bring it up to speed to the latest version, yes, your PLC could communicate over MQTT and Sparkplug. And in fact, this is the kind of scenario that I would recommend. Certainly, the technology makes it possible. Right now, it's not out of the box. There are missing pieces, but certainly that would be a fantastic way to bring this. And in fact, this is something that I discussed with Alois, the 4DIAC project lead, a while back.
Okay, so it was not so stupid then. Thank you. Thank you very much.
Philippe, everyone knows you're not stupid. Come on. You're the only one dotting. Yes. Any other question or comment? Kai.
So the Sparkplug specification itself obviously doesn't contain any data semantics, no definitions of data. It just provides means to
represent any data.
To send or exchange data.
Yes.
You initially made the comparison to UPC UA, which, to my knowledge, does an extensive job of doing this, defining the semantics of the data as well.
Yes.
So first, I find that comparison a little unfair then, saying that contains a lot of pages, which the other doesn't, because it contains more information than the other. So,
yes.
But apart from that, I was wondering, are there any plans to have also some specifications of data sets for particular domains, maybe, or something?
Right now, no. But if people want to build such a thing, then there's always a possibility. In our ecosystem, from the University of Sheffield, one of the academic members, they put together something called Factory Plus, which is a framework for industrial automation that relies on Sparkplug as the preferred protocol. And in their case, they define a data model, and they provide you the artifacts to implement that easily on the top of Sparkplug.
Yeah.
So nothing prevents anyone from doing that or using, if you want to rely on the OPC UA information models, in Sparkplug guys, you can do that as well, right? And I think for the time being, the community is happy with that. But if we get additional members that strongly believe in a specific information model or data model, then we could see that emerge. And of course, that would be maybe a separate spec or an optional part of the main spec, depending on how it evolves. But that's really up to the spec committers to decide ultimately.
Yeah.
But very good question. Thank you.
Thank you, Kai. I think, first of all, thank you very much. I think it was a very interesting presentation. But I will just close exactly on what Kai said. I mean, having a protocol, getting data, it's of course important, right? But without the semantics, there will be some missing gap here, right? And it of course is up to the standard or to the Sparkplug group to decide whether or not it's relevant, right? Because semantics are really additional payload, and if you are very close to the hardware, it may be not really a good idea if you want to get rather performance. But I just want to raise some ideas because, for example, the S administration shell use semantics from Eclipse.
Yes.
Eclipse is a very, I would say, well-known standard for providing, semantics like a catalog, right? Maybe you guys should have a look at it. Of course, Eclipse is not open, so it's also like it has its own ways to,
yes.
Right? But if you guys want to achieve rather like a broader audience, a lot of big names in the industry are using Eclipse to exactly achieve this purpose, right?
Of course.
So
what I think is that, given that the Industrial Digital Twin Association specifications are more open than ETAS, maybe we can find a way to refer to that rather than the core e-testing, and then we circumvent the issue in a way, right?
I think this would be also a good idea because it's actually not about competitive standards, it's rather how you bring them together. Yeah?
Exactly.
And, it's a good example is like SNMC shell and OPC UA because we don't want at SNMC shell all data because it's not, right? So what we're doing is like a OPC UA or all the companion specs, what data do we need out of there to the SNMC shell? And the same could be done with the Sparkplug. So.
Yeah. There's a whole area of cooperation there, and that's why we need so much to bring a digital twin special interest group in our scope to discuss those things, with the Sparkplug gang and the Eclipse IoT gang. But anyway, yes, very good comment, Tiago. Thank you.
Thank you.
Oh, maybe. And then we get back to you, Kai.
Yeah, so The Covesa group is doing a similar thing for automotive, and one of the discussions I have with my colleagues is, should we use Sparkplug or not? And one of the differences we see is that the organization definition is very device-specific here, and whereas in a car, you don't necessarily want to do that, right? Because everything is more logically... How would you square that, round that square peg?
Those things are not set in stone. So first, from an automotive perspective, what I know is that some of our Sparkplug ecosystems members have been discussing with the US Car Association about adopting Sparkplug for connected cars, generally speaking. Now, at what level and that kind of stuff, I have no idea. So I would have to ask them. But we have already some conversations about it. Right now, the spec is monolithic and simple, but nothing could prevent the Sparkplug specification team to separate the payload format in a smaller, self-contained spec and refer to that in the main Sparkplug specification, for example. This means you could just pick the data format, or you pick the full thing with its behaviors, or we could have maybe an automotive specialization of the spec, or a little parallel spec that just modifies some aspects of it. This is all open source. And so if members on the SDV side are really interested in the tech and will to start a conversation, the easiest way to do so is by creating some GitHub issues on the Sparkplug repo proposing ideas, and from there we take it. And if needed, we organize webinars or whatever, not webinars, come on, Zoom calls to discuss, or face-to-face meetings in order to go deeper. But, the Sparkplug team is quite open to anything that will facilitate its adoption. So how do we round that square peg? That's it, by speaking and seeing how we can build consensus around maybe a different thing than in the current version.
Right. Okay.
And Kai, you had another question or comment. So let's.
My understanding from what you showed is that devices are entitled to publish information and receive commands.
Yes.
And some component somewhere else, an application, if you will, can read that telemetry data and send commands.
Yes.
However, using the architecture with an MQTT broker, on first glance, it would look, or I get the impression, or could get the impression, that devices can see the data from the other devices or send commands to other devices?
It depends on which broker you run, because of course...
No, my point is the broker itself doesn't prevent that because it's a generic pub-sub system. So my question is, does the Sparkplug specification somehow define the roles of these participants and then mandate that these topics need to be access controlled somehow? No,
because access controls are not part of the core MQTT spec. They are typically broker specific, right? So the IFMQ broker, Eclipse Amlin, Eclipse Mosquito, many brokers have their own way to define those things. So it's up to you, and it's deliberately like that. It's up to you to figure out what kind of granularity you need for that access control and which broker fulfills it better than another one for your use case. But normally, okay, and the many, because this is not new, okay, there are tons and tons of real-world deployments of this, but typically access control lists will be used to restrict access to specific topics or sections of the topic next space according to the level of granularity. So no, you wouldn't expect a little device at the end of the chain to see all of the traffic of everything else in the system. However, the SCADA system that orchestrates everything in the factory will see everything probably. Well, thank you so much once again. I appreciate all of the questions, and don't hesitate to reach out if you want to go even deeper. I can connect you, of course, to the team because, well, I'm speaking about this, but I'm certainly no expert about, all of the minute detail in this. Thank you again.